Still within the endomembrane system, we're going to pick up with lysosomes. Lysosomes are small, and sometimes not so small, but relatively small when you compare them to the nucleus, digestive compartments. So they're little membrane sacs, little bags that are created by membrane. Inside that bag is a bunch of hydrolytic enzymes. Those enzymes have the job of digesting macromolecules. So they're going to hydrolyze. Remember your hydrolysis reaction, where we use water to break apart polymers into smaller subunits. So we're going to hydrolyze anything from proteins, fats, polysaccharides, and nucleic acids. So any of those big molecules, any of those macromolecules that we talked about. In the case of phagocytic cells, those cells that can actually engulf another cell or debris, kind of like Pac-Man surrounds those energy blobs or even the ghosts, what's going to happen is we're going to pull in that other cell or that debris into the cell through a process called phagocytosis, and we'll learn that later. And then what we're going to do is we're going to form a food vacuole. So now I've got this pouch inside a cell from whatever we've pulled in, whatever we've engulfed, and a lysosome will come along and fuse with that food vacuole and digest the molecules. Lysosomes are also responsible to do recycling within the cell. So as the cell's own organelles and macromolecules need to be broken down, say an organelle wears out, then the lysosomes will come along and take care of it. That process is called autophagy. So here on the left, this is phagocytosis, where a food vacuole has been formed at the membrane. So this is the cell here. This is outside of the cell. This is extracellular, and this food vacuole is going to form. It's going to get pulled into the cell cytosol. A lysosome filled with its digestive enzymes are going to come along. It's going to fuse, because remember, this is made up of plasma membrane and this is membrane, so those membranes are going to fuse together very nicely. And then we're going to create a digestive pocket here, and we're going to be able to use some things from there. In the case of autophagy, in this case we've got a worn out mitochondrion here. So we've got a worn out mitochondrion. Here's a peroxisome. We'll talk about them in a little bit. We're going to get this vesicle with this mitochondria and this peroxisome. A lysosome with its hydrolytic enzymes is going to come along. It's going to fuse, and we're going to break it down. Pretty snazzy, pretty easy. Vacuoles can be very, very diverse, and we need to differentiate between vacuoles and vesicles. Remember what we spoke about vesicles doing a few slides back. Okay, we talked about vesicles doing something. Vacuoles are different. They're more for storage. So plant cells, fungal cells can have one vacuole. They can have many, many, many vacuoles. Food vacuoles get formed through phagocytosis. Contractile vacuoles are found in a lot of the freshwater protists, and it's how they pump out excess water to keep their shape and to keep from rupturing. Central vacuoles are found in mature plant cells. Their job is storage. It's to hold organic compounds and water within that cell. So different forms of vacuoles. So you want to be able to go back and say, what's the difference between a vacuole and a vesicle? And this is very, very simple. This is a one sentence, two sentence at the most sort of answer. So if you don't think you have a good answer, or you want me to tell you if you've got a good answer to this question, go ahead and just shoot me an email, leave me a message, and I'll answer you back. But you should be able at this point to differentiate between vesicles and vacuoles. I'm going to stop here because we're going to leave the endomembrane system, and that seems like a good point to break to do that.